compositions. Okay, now what in the world does this mean? If they give us f of x and g of x, and we want to find a composition, so we want to find g of f of x. This is really simple if you just kind of remember how this pattern works. Okay, so let's take a look at just a couple of these. Okay, positive exponents, simplifier x, well, that's not good. All right. Okay, now think what this means. If f of x is x squared minus 4 and g of x is 1 over x minus 5, let's take the g of x. If g of x is 1 over x minus 5, what is g of a? Well, here, let me try a different one to start with. What is g of... That seemed a little weird. What's g of 7? What does that mean? All that means I'm evaluating my function g of x at x equals 7, right? So if the x is becoming a 7, what's that do to my answer? Okay, good. So I get 1 over 7 minus 5 equals 1/2, right? That's all we're doing. Now think what this means. When I write this using function notation, it's just a recipe. All this equation is telling me, or this formula is telling me, is what am I going to do to the x's that I'm feeding into the function? I'm going to do this to them. That's the recipe for how we deal with the x's that we're feeding into the function. Do they have to be x's? No, we just put a 7 in there. And it gave us back this answer because it followed that same g recipe, right? So then what am I going to get if I put an a in there instead of an x? What's that going to be? I think I heard it. 1 over a minus 5, right? Because now if I feed it the a, it's going to do this recipe to it. It's going to be 1 over whatever I feed it minus 5, right? Okay, what if I feed it, now this is the weird part, what if I feed it something like f, okay, where f is actually a function? So what's g of f going to look like? 1 over f minus 5. And what if f is actually this? What if f of x is actually x squared minus 4? There you go. So then the x squared minus 4, this part right here, is going to go right there, right? So it looks like if f of x equals, what was it, x squared minus 5? Minus 4, okay. So if f of x is x squared minus 4, then g of f of x, just equals 1 over x squared minus 4, because that's my f of x, minus 5. That's it. Okay. And if I wanted to, now I'm pretty sure this one says, no, never mind. Okay. So then if I simplify that on the bottom, if I add like terms, what's x squared minus 4 minus 5? What's x squared minus 4 minus 5? Do I need those parentheses on there, really? I put them in there so we can see that that's f of x, but I don't really need them. X squared minus 9, yeah. Negative 4 minus 5 is just negative 9, right? So my final answer then just looks like 1 over x squared minus 9. Okay, that's all I'm doing. Not that big a deal. All I did was I just fed, if I'm taking g of f of x, every place that I used to have an x, I'm now putting in an f of x. Big deal. Okay. What if we took that same problem, Questions on that? Okay, what if I said this? What if I said instead of finding g of f of x, this time I want you to find f of g of x? What's that going to look like? Okay, so that's going in there. Now it used to be if f of x is x squared minus 4, f of hand is just hand squared minus 4, where what's behind my hand doesn't matter. Could be an x, could be a 10, could be whatever. Whatever's behind my hand is just going to go right there, isn't it? So if it's a g of x, then I'm just going to have g of x squared instead of x squared minus 4, right? So that just looks like, right? Does that make sense? Okay, because this is g of x. And that's what I do to it in f. When I feed the f function something, it squares it and then subtracts 4. So if I wanted to simplify that, well, what would I do to simplify that? What do I do if I square a quotient like that? What's this? If I have a over b squared, what's that equal to? A squared over b squared, sure. All right, just distribute the power. So then this is just going to give me 1 squared over x minus 5 squared minus 4. So really all I'm getting is just 1 over x minus 5 squared minus 4. And that's good enough. We don't need to go any further than that. How come I'm not? Say it again. I can't because the 5 is in the denominator of a fraction, and it's being squared. Right? In the last example, I could because they were just numbers that were all being directly added or subtracted from one another. Here, they're in separate terms. I can't do it here. That's as far as I can go unless I want to. I mean, to simplify that would be a major pain. It wouldn't really accomplish anything. We could FOIL out the bottom and get a common denominator, but we don't need to. We don't need to. All I want you to do here is just give me what the formula is going to be. I don't need you to go any further than that. Okay. In fact, really, this would even be fine right here. That's the right answer. Okay. If we graphed it, that would look like what we needed it to be. Okay. Questions? Okay, so that's what a composition is. Oh, I know one more I want to do with that, real quick. What if I said, this is a little strange, but what if I said like, oh God, what's f of x? Yeah. Then whatever I'm feeding into the f, I'm doing this to, right? So that's just going to equal what's being fed to it. Whatever's being fed to it is being squared, right? Well, it's just f of x. So I get that. Well, f of x is the quantity x squared minus 4. So that's my answer, right? The quantity x squared minus 4 squared minus 4. That's all I've put. You don't have to go any further than that.